Now let's talk about protocols that are implemented at transport layer of the TCP IP model. So we have discussed that TCP and UDP are the protocols that are implemented at transport layer. So let's discuss about TCP and UDP protocols and the difference between these protocols. So TCP is basically transmission control protocol. Alright, and UDP stands for user datagram protocol. TCP is basically a network communication protocol that is designed to send data packets over the internet. If I just talk about TCP and UDP, so these are the protocols that are designed to send data packets over the internet. Both of these protocols are designed to send data. Alright, but here is the basic difference between TCP and UDP, and that is related to the three-way handshake model. So if we are talking about TCP, so it's a connection oriented protocol. It's connection oriented, and UDP is connection less protocol. Now what is connection oriented and what is connection less? So if you know about three-way handshake, let's just talk about three-way handshake. Three-way handshake is basically a method of sending and receiving the data over the internet. It uses basically 3 steps. That's why it's called three-way handshake. Like if we have client and a server, so if client is requesting for any information, it's basically forwarding any request to the server. That means it's forwarding the synchronization packet. That packet is also known as SYN, S-Y-N, SYN. Alright, so client is forwarding SYN request to the server. When server received that request, it forwards the packet that contains this acknowledgement and the synchronization packet with that. Alright, the combination of synchronization and acknowledgement packet. So that means first client has forwarded SYN packet, then server has forwarded SYN plus ACK packet to the client, and at last client will forward the acknowledgement packet to the server. So that means here you can see we are getting acknowledgement from both ends. Like server is also forwarding SYN plus ACK packet, that means acknowledgement packet. So server is also acknowledging the client that yes, I got your packet, yes, I got your request. Alright, and at last client is forwarding acknowledgement packet. So client is just accepting that yes, I got the reply. Alright, so this is the connection oriented method here, where you are getting the complete acknowledgement of all the packets of being transmitted and being received. So here the acknowledgement is necessary. Where you are getting acknowledgement, that means that is connection oriented protocols. And if we are talking about UDP, that means connection less protocols, where you are not getting any acknowledgement. Alright, like let's say like you are using walkie-talkie or radio channels. So these are the examples of UDP protocols. Hey, there you are not getting any acknowledgement. If user is forwarding, if client is forwarding any packet, so it's just forwarding the packets. The server is not replying back with the acknowledgement. Alright, so TCP is connection oriented protocols and UDP is connection less protocol. So this is the basic difference, depends upon three-way handshake, and in three-way handshake we have 3 steps. That's why it's called three-way handshake. First, client forwards SYN packet to the server, then server forwards SYN plus ACK packet, ACK, that means acknowledgement, SYN, SYN, SYN plus ACK, acknowledgement packet, and at last client forwards ACK packet, that means acknowledgement packet. So this is the way to communicate over the TCP network, or by using TCP protocol. So TCP provides extensive error checking mechanism, because here you are getting acknowledgement of all the packets, so definitely you can check the errors between them, or between the communication channel. All right, UDP is a very light protocol defined in RFC 768, and it's connectionless. UDP is efficient for broadcast and multicast type of network transmission. As I said, you can use it you can take an example of walkie-talkies or radio channels. All right, so UDP is used for broadcasting the packets, or broadcast in a particular transmission channel where you need to broadcast a particular information or multicast networks. All right, so these are the two protocols, TCP and UDP. Now let's talk about internet layer networking protocols. Here you can see we will be discussing 4 protocols: IP, ICMP, IGMP, and IPsec. So IP is internet protocol. As most of the people know today, is that what is IP? It's internet protocol, and we have 2 versions of IP address, IPv4 and IPv6. IPv4 is the older version. Now our network is configured with IPv6 version 6 technology. IP is basically underlying technology that makes it possible for us to connect our devices to the web. All right, so we have IP, internet protocol, that is used to connect the devices to the web. Next we have ICMP. It's basically control messaging protocol. All right, it works on internet layer that provides troubleshooting, control, and error message services. It's basically for controlling the messages over the internet. And same like that, we have ICMP v4 version, the 4 version, and 6th version. So today we are using version 6. Then we have IGMP. It's group management protocol that mainly manages the group membership in a multicast network. So it's IGMP, group management protocol. Next we have IPsec. IPsec is basically for IP security. As I said, it's for internet protocol security. So in short, it's known as IPsec. It's a secure network protocol suite that authenticates and encrypts the packet of data sent over the internet protocol. So basically, if we are using IPsec, so here is the basic difference between IP protocols and IPsec protocol is that IPsec protocols are secure protocols that uses the encryption technology for making the packets or the communication network secure. So it's IPsec. Then next we have network access layer networking protocols. So these are the network access layer, and we have Ethernet, token ring, and frame relay. So first let's talk about Ethernet. It's a technology that is used in wired local area networks, or basically local area networks, metropolitan area networks, and wide area networks, enabling devices to communicate with each other via protocol. Many people use Ethernet technology their whole lives without knowing it. It is likely that any wired network in your office, in your college, in your school, at your home is an Ethernet LAN. All right. Most of our desktops and laptops come with an integrated Ethernet card inside, so they are ready to connect to an Ethernet LAN. All right, then we have token ring. So token ring is basically a LAN technology that is a communication protocol for local area networks. All right, it uses a special 3-byte frame called a token. and that travels around a logical ring of workstations or servers. That's why it's known as token ring, because here we have token and a ring of workstations. So this technology is a communication protocol for local area networks, and in token ring, nodes and stations are arranged in a ring topology. That's why it's known as token ring protocol. Next we have frame relay. So frame relay has evolved from X.25 packet switching, and objective is to reduce network delays, protocol overheads and equipment cost. It's basically a standardized wide area network technology that specifies the physical and data link layers of digital communication channels using a packet switching technology. It's basically designed for transport across integrated services digital network. Alright, so we have Ethernet, token ring and frame relay. These are the protocols that are used at network access layer. So we have discussed all of these protocols on TCP/IP protocol stack. Now in the next video we will be discussing IP addressing concepts. Alright, thank you.